Hello everyone, it's April 28th, and it's going to be a little bit strange today because I'm not at home right now. I'm actually traveling. I'm in Dallas right now, visiting my girlfriend's mom. So we have to do this in a different setting, and it's kind of late. They all went to bed, so I have to talk very lightly, don't talk too loud. Anyway, even though we're on the road, we're still going to do it. I mean, this is a promise that we make to ourselves. So we're gonna keep working on this and never give up. Don't miss a day. All right, let's take a look what we have. Uh, Whatever it is, I don't remember commenting on any of one of those. Anyway, let's see. What do we have today? Unique paths 2. Have we done 1 before? It's a matrix. I don't like matrix. All right. A robot is located at the top left corner. Okay, it's here. Marked start. The robot can only move either down or right at any point in time. Robot is trying to reach the bottom right corner. Now consider if some obstacles are added to the grids. How many unique paths would there be? An obstacle is marked as 1 and a 0 respectively. No, the obstacle and the space is 1 or 0. So the unique path will be this way, this way. That's it, because they only go right or down. Okay, 2 ways, right, right, down, 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 right, right. This is just a 1 way. Okay, we'll have 100. I have 3 hints. This looks very similar to the reinforcement learning problem that I have solved, many of them during my class, but this is definitely not going to be reinforcement learning. This is going to be just a straightforward analysis. And apparently, because we can only go right or down, that reduces the search space. So I think it's actually possible just to run a traditional DFS with backtracking. And just a backtracking algorithm. I think that shall work, right? And starting from here, we can either go right or go down. We just keep going, and then we reach it, and then we step back and trying to see if there are other ways. Now, the thing is, it requires a unique path, right? Unique path doesn't require the shortest path or anything. It's just a unique path. Let me think. So, as we go, like we go right, and then we cannot go down, so we can only go right. And then from here, we say we'll go down, and then we'll reach the target. So at each state, at each cell, we have 2 ways to go, either right or down, right? And then what we can do, so the answer is to count how many unique ways, which means we can count how many unique ways it is to go from here. So what we can say is the number of unique ways that we can reach the target starting from this state is the sum of the unique ways that starting from this state and this state, because they are 2 different ways. So the ways that starting from this state will always be different from the ways that start from this state. So we can add them together. So for each of these, we can do this type of thing. So the number of unique ways starting from this cell will be the sum of this, and this will all be 0, so it's just like equal to this. And this cell will be from here, and this cell will be from here. This cell basically just say one way, right? So this will be 1, this will be 1. This, if it's not here, not this will be 2, because we can go 2 ways, right? Maybe we can build it up like a bottom-up solution. We don't have to do a top-down. We can, yeah, it is, because for the column, for this column, it's always going to be 1. So this will only be 1 because there's no way to go. There's only 1 way to go. So this will only be 1. This will always be 1. And then we just try to fill up the rest. Let me draw it out in a little bit slightly bigger, right? A slightly bigger grid. I think we might be able to solve this just by doing bottom up instead of the top down. And m times n, so it isn't necessarily a square. So anyway, so this is our target is at here, right? So everything surrounding the rightmost column and the bottom row will always only be 1. There's only one way to go. Now we can try to fill up. We can fill up like this and then this. Feel like that, that should work, right? So the rightmost column and the bottom row, and the next one will be the second rightmost column and the second most bottom, because we have, I might just be talking out of my butt right now. But yeah, so these are 2, right? That was actually 2. That will be 3, that will be 4, that will be 5. I'll say this has 2 ways. This has 1 way, 2 way, 3. Oh yeah, that's 3. So no, so it's actually we fill up this, and then we start filling the column by column. That will be 3, that will be 6, 10, and 15. I'm actually doing one myself and then trying to see how this one work out. And this was just diagonal. We adding diagonal. Oh, and this is actually symmetrical. Diagonal will be 20. This will be 35. And this will be 35. This will be 70. So let's just set a 1, 2, 3, 4, 5. A 5 by 5. Let's try a 5 by 5. See if it is 75. Just to test the hypothesis that I have right now. See if it works. So 5 by 5 will be, and then we have no obstacles. So that's 5, right? That's 5. So we're going to do this 5 times. 2, 3, 4, 5. Oh, the answer is 70. 70. See if it's 70. Yep, it's 70. So this is the correct idea. This is what we build from bottom up. And then for each cell will be the sum of the neighboring cell. Now we're going to involve obstacles. So an obstacle just means at that point we have 0, right? So if there's an obstacle, then we just say it has a 0. Let's say we have 0 here, right? We have an obstacle, second row, let's put an obstacle there, and let's see what's going to happen. So what's going to happen is the sum will be 15 here, and the sum, right, is 15 here, and then it's 15 here, so this will be 30. So I think this result shall become 30. Let's see if it's 30. Yep, so is it correct? We can code, start coding. Everything is jammed because I don't have 2 screens. Usually when I record on the screen, and I have another screen for me to do other stuff. But now I only have 1 screen, and you guys kind of see other stuff. Let's hide the other stuff. I wrote some thoughts earlier on an article that I read, but that's not something I need to discuss right now. And yeah, well, if we might discuss the other side of me in the future. But right now, let's just focus on solving this problem. Okay, so we're gonna start from the bottom right, and then we're gonna go up. And the idea is, oh, it is. I don't have to go on a column. I have to go on column and column. I mean, we will go column by columm. We can also go row by row. I mean, row by row will be easier to write, I think. But it's the same thing, right? It's the same thing. So if we go row by row, Yeah, let's do row by row. Actually, yeah, let's do row by row. That's fine. So I think row by row will be easier to handle. So we need a DP. I call it DP. So it's gonna be 0 times again m n equals len obstacle grid and len obstacle grid 0. Let's see if there is a restriction on the size. Oh, the 1, so that's fine. And this is gonna be rows, right? And then I'm gonna say for underscoring range, and that's the column. Okay, so that's our DP, and we can pre-populate the bottom row and the rightmost column. So we say for J in range what? In range n, right? DP m minus 1 J equals 1. Then for I in range m, then DP n minus 1, nope, I n minus 1 equals 1. Right, so we got these two, then we decide to go row by row. Oh, hold on. You cannot do this because we have to also check if it's a 0. Yeah, if we have a block, on the bottom, then we cannot do. Right, if I have a block on the bottom. Oh, if we have a block in the bottom, we probably have to do this slowly. So we cannot do all this because we might have a block in the bottom. If I have a block in the bottom, then yep, it depends. If we have a block in the bottom, then it's a very different story. Okay, so what we have to do is hold on. So what we have to do is to identify. So let's do it slowly. It's not gonna be this. We're gonna do reverse style, which means it's going to be J is going to be from n minus 1. Well, but n minus 1 is the target, so it's actually n minus 2 to this, right? And we say what do we say? We say if it's an obstacle, then it's a 0. If it's not an obstacle, it should be like until we hit an obstacle, then everything else is 0, right? So we're going to just say the val is going to be 1, right? And we say if obstacle, right, m minus 1 j is equal to 1, that's obstacle, then value becomes 0. And then we're going to populate dp m minus 1 j can equal the value, which means we're going to start 1, like 1, 1, 1, 1, 1, until we hit an obstacle. Once we hit an obstacle, everything else has to be 0, because there's only one way for the bottom row to go. And if there is an obstacle, then everything to the left of the obstacle cannot move. We cannot move. So that's basically what this means. And we're going to do exactly the same thing to prepare for this as well. Right, we're going to prepare for this as well, but just a bit different. So this is going to be for I, right? For I in range, this is going to be m minus 2. And we say obstacle I and n minus 1, right? That's the rightmost column, and then we say if it's 1, then value is 1. Otherwise, we're going to populate I, and n minus 1 equals val. So we populate these, and then we can start going. We can start going for it. I mean, it doesn't really matter how you go for it. Like I said, I want to go row by row, but it's also possible to do it column by column. Let's just go row by row. Go row by row, then we say for I. Let's write some comments. Say populate the rightmost column and bottom row, right? And then this one going to be populate the remaining cells. So we say for I in range, so we go 1 up, right? 1 up will be 1 up will be what's 1 up? M minus 2, right? M minus 2. So M minus 1 we already handle. So M minus 2 and minus 1, right? So it's I. Then for J in range, it's going to be from right to left. So it's going to be N minus 2, right? N minus 1, N minus 2, and minus 1, right? So as we go through the J, so we're going to say dp I J equals dp I plus 1 J, so this is the bottom, just like below it, right? And plus dpi J plus 1, that is to the right. So we use these two values. If, now it's actually going to be here, 0 if obstacle grid ij, right? If we have an obstacle, then it's going to be 0, which means we cannot go there, right? If it's 0, we cannot go there, which means the total number of is, yeah, so we cannot go there. So it will be like this. And I'm actually thinking, would it be, can we combine the setup and the actual population into one logic? We can just add one column, add one row, see if that one works. This one will equal this plus this. Yeah, we can just put it as minus 1. No, that will be, no, I think this, yeah, I'll just stick with this. So this would populate everything, and then we're going to return dp00, right? dp00. Okay, let's run a few test cases. We have, if I remember correctly, I was going to say forget it correctly. We have 4 test cases actually. We have 3. That's from, I have 2. That's from the one that LeetCode gave us, and we have also 2 that we created. This is going to be 1, and we have, this is our creation. Right, so this one is 30, and I remember this one is 70, which does not have an obstacle. Okay, and we're going to populate, handle all the commas, and there are actually a lot more that I can think of that we can do. That'll be interesting, because I can add obstacles to everything and see if that's how if the result is how we expect it to be. Unique. This is going to be obstacle grid. Okay, try to run it, and we pass all of them. That'll be interesting. Like for this one, right? Let's just, if we put everything as 1, I think the result should be 0, right? the result shall be 0. Yeah. And I want to just try some random ones. I should say random. Just pick a few. Don't get too many. And kind of see how this one works. I'm gonna paste this code there. We're getting close to submit, but I just want to run a few more test cases. Yeah, I think we're correct. All right, let's try it. Pending. Ooh. Ooh. We got bad. Oh. The end. Well, well, well. I did not expect that to happen. I didn't realize this could be a test. This could be also a valid test case. I mean, in that sense, this shall be a valid test case as well, right? The starting and ending can also be, yeah, we handled the end and we didn't handle the start. Oh, we handled the start, we didn't handle the end. I mean, I think it'll be handled fairly easily by just changing the condition. Instead of n minus 2, y or j start from n minus 2. Yeah, we don't have to, we just start from n minus 1. And this is also starting from n minus 1. Yeah, then we pass. So basically, we can start from n minus 1, and that's all n minus 1. Alright, try it again. Pending. Shoot. List out of range. How? How? Wow, this is the edge cases. Shoot. All the edge cases. I don't think this is 0 though, man. That should be 1. Oh man. M is 1. That's 1 row, right? That's 1 row. And I say 1 row, then M is 1. Index out of range. M is 1. 1 minus 1 is 0. J is n minus 1. Right? N is 2. Right? So it's from 1 to 0. Why would it be out of range? How is this out of range? Like say DP is out of range. What? Hold on. I don't understand. These all pass. I don't need you to pass. DP should be right. DP is 0, 0. Hold on. DP doesn't look right to me. Oh, shoot. This is N. This is M. This is just, this is a bug. I wasn't, dang it. Why would I, how did I mess that up? No, this one passed, we know. And how do the rest of them pass? Huh. All right, try it again. Third time. Yep, now we get it. It's not hard. It's not hard. Probably medium. So the intuition is for is that the number of unique paths starting from any cell equals the sum of the unique paths starting from the cell to the right and the cell to the right and to the down to the down and to the cell beneath. So equals the path starting from the cell to the right and the cell beneath. Using this relationship, we can solve the problem by in a bottom-up fashion. We first can determine the number of unique paths starting from the cells on the rightmost column and bottom row. Since there is only one way to go from there, and then we can expand backwards toward the starting point. The tricky part is when an obstacle happens on the rightmost column or bottom row. Not only is that cell's unique path equal to 0, but all the other cells above it or to the left of it are also assigned 0. So it's OMN, where M is the number of rows and N columns. I still cannot believe I messed up this N and M. Could have done it with fewer failures. Still, it's like too many failures. I was expecting this to be done like one failure, but let's give us too many failures. Wasn't careful enough. That's 49% ranking. Okay, let's see if the official solution has anything more to offer. I don't think so. I think our solution is quite standard. I think it's a medium question. Yeah, I think it's a medium question. So it's LeetCode 63. Oh, I've done it before. I think. Yeah, 2019. Only one wrong answer. I got 2 wrong answers today. Solution, dynamic programming. Oh wow, that's a lot of code. Number of ways of reaching the starting cell. Fill the first column. The value is on the first row. How'd you fill on the first column and first row? Return must ask you for more than one approach. Compare the approaches. That's just stupid. Why would you ask for recursion when the iterative is faster? I don't really think so. Let's see how people discuss. All right. How did you go from this one to the... Oh, it's this... can only be reached from the cell left to it. Ah, I see. So it's slightly different thinking. So what I'm thinking is the cells on this row, on this column, and this row can only reach the finish line in one way. Well, their thinking is the cells on the first row can only, like this, can only be reached by one way. So the thinking is slightly different. What I'm thinking is how many ways can you have to reach the finish line from any of the cells. So I think of each cell as a starting point. But what they think is each cell as the end point, right? If you think of each cell as the end point, you're starting from here and you converge here. If you think about each cell as a starting point, you're starting from here and then converge here. But the overall idea is the same, right? So we can try to also parse. We have this is the edge case. Okay, so when I say 0 and obstacle, oh, that's a good way of saying. If the obstacle is 0, I0, okay, so that's the first column. First column, yep. And obstacle grid. Oh, they're changing it on the obstacle grid directly. An obstacle grid I minus 1, 0, it's the previous one, is equal to 1. Okay, so it means the current one will be, say if it's 0, and the previous one is 1, then true and true, then I become true, then I'm 1. If the previous one is 0, then I'll become a 0 as well. If the current is 0 and the previous one is 1, it's false, then it will be false, and this one will be 0. If the previous one is 1, now the previous one is 1 means it's good, right? It's good, it can be reached. So if my current is 0, okay, so if my current is 1, then the previous one is also 1, then I become 0. Ah, that's pretty smart. That's pretty smart. That is pretty smart. So if my previous one is 1, which means it can be reached, and currently I can be reached as well, so I will be 0. If my previous is a 0, which means it cannot be reached, then whether I current is 0 or 1, doesn't matter, I'll become 0. Pretty smart. Pretty smart. How did I do it? I think I have a if and else. I set up this. This is my way of solving it. Doesn't matter. Okay, starting from here. If it's a 0, then do this. Otherwise, yes. Yep, it's the same. It's the same solution. Same solution. Short Java. Well, that's 2015. Ooh, didn't do anything else. If row J is 1, return DP. Oh, that saves. Maybe we can. Maybe we can save. Can we save? I only use one a 1 array. How did you use 1 array? How did you use 1 array? We don't need to store the whole 2D, but instead store value in 1D and update data by using dj corresponding to dp this and then dp j minus 1. Oh, hold on, this one deserves more thinking. We only need, like for each one, we only need in my case, we only need the j plus 1 and I plus 1, right? Now these are the only two that I need. For this, I only need these two. For this, I only need these two. For this, I only need these two. Yep. So therefore, it is possible. For this, I need these two, and I can get this value. And then for this, I need these two. So I need to save this, right, plus this. And every time updates, I update this, right? Then, no, I don't update this. I update this. This will be this. Update this. So it'd be 1, 1, 1, 1, 1, right? And then 2, and then when I update this plus this, it's gonna be 2, right? And then it's gonna be this plus this, it's gonna be 3, this plus this will be 4, this plus this will be 5. Going up, we need to first compute this value. This value is 1. And then we're gonna compute this value, is this plus this, 3, 6, okay? So what if it's 0? Well, say if this is a 1, it'll become 0, right? And then we're coming back up, we need to check. We need to check, right? There has to be a check to make sure that it's always 0. I don't know. I honestly don't know. But this gives me thinking, but I'm gonna try code it myself. What if it's a 1? If it's a 1, we set it to 0, which is fine. What if it's not a 1? It's not a 1. By the way, previously we already have a 1. And it should still be 0, which means if we see a 0, then it remains a 0. Alright? So this value, if the value beneath it is a 0, so I will be a 0. So I have to run an additional check. Yeah, I have to run additional check. But it's possible. Let's try it. Let's try it. Let's try to use the 1, right? We only use a 1D array. 1D array for DP. Yeah, we should credit. My DP solution, very simple. Yeah, it's all. I wonder why they all work. I think I can just set them to 0 initially. Yeah. Yeah, I think I can just set them to 0 initially. Anyway, so credit is going to be here. Yeah, I think I can just set them to 0 initially, and then I'm gonna see if it's something, and then we don't do it. And if it's a 0, we always sum. If the previous one is a 0, right? If the previous one is a 0, then no, we still need to handle the special case. At the bottom row, we have to handle the special case. Like if we go and we find a 1, or we find an obstacle, then we set that to 0, and then we keep going. And we keep going, then we know it's a 0, so it has to be a 0 as well. It has to be 0 as well. Then we start rolling. For this one, we're going to see if it's a 0, then we set it to 0, and then we do whatever we need to do, and then we go up a row, and then when you look down, right, look down, if it's a 0, then I must be a 0. If it's not a 0, then I can be either a 1 or 0. So DP for sure is just going to be, no, we have to do this as well at the beginning, right? And then DP is going to be 0 times number of columns, right? Number of columns. And then we're going to say DP n minus 1, right, equals obstacle grid m minus 1, that's I, it's this one, equals 0, right? Equals 0. If it's 0, that one has to be 1, otherwise it's going to be 0. And then we're going to say for j in range, right? For j in range in minus 2, minus 1, minus 1, I'm going to say dp m minus 1, no, dpj equals what? dpj equals, first of all, obstacle m minus 1 j. If this is equal to 0 and dp j plus 1 is equal to 1, right? And then we turn that into an int. Yes, I'm following the solution. If it's accessible and my previous one is also, my next one is also accessible, then I am accessible. If I am not accessible, then it's going to be 0. If my next one is not accessible, that's going to be 0. Yep. So that's the bottom row. We're ready. And then we're going to go for I in range. Let's say prepare bottom row, right? And I would say for this in range m minus 2, minus 1, minus 1. And then for j in range, so for j in range, well, we have a special case to consider. It's the right column. It has like a special case. If we don't do special case, then it's going to be wrong. Right? So in range n minus 1. No. Oh, yes. N minus 1, minus 1, minus 1. Right? Then what we do is we're going to say dpj, right? dpj will be the bottom row. If j equals, otherwise it's going to be them summed together. So what we're going to say is, what are we going to say? If j is not an obstacle and the bottom one is 1, then I am going to be, so say if j is equal to n minus 1, right? Then dpj equals obstacle grid I, j, if that's 0, and dpj is equal 1, right? So if that's the case, then we're going to int this, and we're good. And if not, either the current one is an obstacle, and or the previous one is an obstacle, then it's going to be 0. Yes, it's fine. So else dpj plus equal dpj plus 1, right? pj equals these two plus together. Yes, so once this done, I'm going to also put it here, pair bottom row, and then go through the rest of the grid. After we're done, go to the top, so we're just going to return dp0. Okay, let's try this solution. Oh, we have some failure, so we need to take a look. We pass most of the other things. Okay. Answer is 2, result is 6. Huh, interesting. Oh no, it's not. It's dp equals dp equals dpj plus this if equals 0 if obstacle. Forgot to consider ij equals 0. If ij else, there we go. That's it. That's the case. Okay, so 1D array for dp. Same method as solution 1, but shrink the memory use. Okay. Submission. Submit. What the heck? Output is true. What? Why, what? I int everything. Oh, wow, I forgot. It's an int. This is unexpected. Yep. Well, that's actually even faster. Why would this be faster? It's the same thing. I don't know. But this has to be int. Well, I guess it's because we didn't run this way. I have a lot of checks, but we have to do checks here as well, right? Every time you have to do checks, and then after you run check, I mean, okay, one thing is we only do check once, but then this one is easy compared to this. I don't know, maybe traversing a 2D array is slower. I guess. Doesn't matter, right? Okay. I want to read this again. Row. How does this work? It's like, seriously, how does this work? Start from 0, and then what? J equals 0 to, we go through each row, and we say row J, if row J is equal to 1, dpj is 0. If j is larger than 0, j is larger than 0 means it's not the first one. Okay. Okay, think about it. This is going the answer route. We're trying to pick each cell as a destination. And if it's 1, then we say destination input. If it's 1, it's 0. If it's not 1, and j is larger than, and then dpj plus equal to dpj minus 1. Okay, j minus 1 is going to be 0 minus 0, and if it's maybe I can use that too. No. If row j, like if the column is 1, then we set it to 0, right? If it's 1, then we set it to 0. If it's not an obstacle, then we set it to the sum of the previous one. If it's not an obstacle. Yeah, this is actually correct. I think this is even a better solution. What's the difference? Like, how do I code it this way? It go row wise, right? Row wise. And we say if it's 1, then it become 0. If it's not 1, right? If it's not 1, so I guess no, it doesn't make any sense. The column doesn't make any sense. Yeah, the column doesn't make any sense. If we have a 1, no, I don't think this is correct. I don't think this is correct. Well, this is actually, we have to swap to Java. Oh shoot! I only write this part, right? Yeah, we're just gonna run some test case. Let's put a 1 here. Let's see if it passes. No, I don't like this test case. Like, if we have, because what this says is, when I start, like if I have 1 here, right, then all these have to be 0, but in this solution, they'll always be 1. Let's add more. So yeah, just add another 0 here. How could this be correct? How could this be correct? It is correct. What the hell? It doesn't make any sense. Row J, if it's 1, then it's going to be 0. And everything, well, I agree. I agree, right? So it's going to be 1. Especially the first row. And I didn't even consider the first row. Right? J equals 1, that's going to be 0. But otherwise, it's going to be dj plus So everything is 0 to start with, so the first row is always going to be 1. Okay, now consider the second row. The second row, the first one, we say if it's 0, then it becomes 0. Okay, and then if j larger than 0, which means j is equal to 0. Oh, if j equal to 0, then I don't change it. Ah, now I see. This is the smart part. So I say row j is equal to 1. I always set it as 0. And elif, if row j is not equal to 1, then we have two situations. Either we are on the first column or we are not on the first column. We say if it's on the first column, then we do not change. We just maintain whatever the value is from the previous column. Otherwise, we do the change, which means it's dj equals, dj is here, equals dj plus, okay, that makes perfect sense now. It makes perfect sense now. I think I need to upvote that answer even more. Can we reset this? Yeah, just reset this. So in our case, can we make this even simpler? That what this means, we don't have to. We probably still need to do this, right? And then we just say, for this bottom row, right? It's either if it's a 0, if it's a 1, if it's an obstacle, it's going to always be 0. If it's not an obstacle, right? If it's not an obstacle, oh, they just combine these two situations together. Oh, that's smart. That's very, very smart. That's very, very smart. Very smart. Basically, we combine the two situations together. Wow. Yeah, so instead of like doing a diagonal sum, we can imagine a diagonal sum even on the bottom row. We can do this like quote unquote diagonal sum as well. Yep, this is very, very smart. Very smart. Right, and then we do need to get this, and then we're just gonna be for I in range m minus 1 minus 1 minus 1, right? And then for j in range n minus 1 minus 1 minus 1, right? And then we simply say for each one of these, well, it's actually not n minus 1, it's n minus 2. And we say if obstacle grid ij is equal to, right, is 1, then dpj, right, dpj is going to be 0. That is no problem, no question about it. Otherwise, right, else means it's a 0, and it's a 0, it depends, right? If it's else, we say elif j is not equal to n minus 1. So j has to start from n minus 1. And then I don't need this. j starts from n minus 1. And we say elif if j is not equal to n minus 1. Right? J not equal to n minus 1. Then we say dpj will equal to dpj plus 1 and plus dpj as well. And we can do this because initially it's all 0. So if it's a 1, we can add. That's fine. That's basically say we just have a bottom, we have another one. Yeah, we just say it's essentially we say we add another row even beneath the bottom row, and they're all considered zeros. And then, yep. So it's plus equal to dpj plus 1. Right? And if it is equal to n minus 1, which means it's on the rightmost column, if it's on the rightmost column, then we basically say we don't do anything. We then extend. This is marvelous. And then we're gonna return dp0. So 3. Ha! The hell. If obstacle is 1, then dp is 0. Otherwise, we need to start from 1. Yeah, we need to start from 1. That's why we need to start from 1. That makes perfect sense. Initialize. And then, yeah. This is so good. This is almost a carbon copy of the solution in here, except that we start from the bottom right corner, going backwards to the upper left. A very brilliant solution. Know that we consider the rightmost column by not making any update when by not making any update. This means if we have a 1 in the cell below, we will always have a 1 in the current cell as well. Otherwise, we will always have a 0. Very smart. Yeah, very smart way to handle it. Alright, this will be our last one, and we will be done for the day. It's not too bad, isn't it? Nope, I don't think it's too bad. Yeah, this is brilliant. Very, very good solution. Yep, very good solution. Alright, that'll be it. That'll be it for today. I mean, we survived, even though we are not in the comfort of our own place. I'll see you guys tomorrow. Adios.